Okay. And is my little speaker thing working?
Say something.
Okay.
Yeah.
Okay, thank you. All right, it's 1:40. Here we go. Before I took questions about anything, at the very end of the class last time, the last problem that I worked, when I wrote down the answer real quick, I put a bracket where I should have put a parentheses, and I didn't have opportunity to tell you because we were finished recording. So I wanted to show you that problem one more time and just talk about the answer so that everybody did have the correct parentheses, okay, in there. The last problem we were working, I have put the notes up real quick on the board here. We were working a rational inequality, and it was 5 divided by x plus 4 is greater than or equal to 1. And remember, we have to get the fraction, get that number 1 on the other side, so it's in reference to 0. We had to combine it so that we had one fraction. Then we had to find out what made the numerator equal to 0, what makes the denominator equal to 0. So all of that is the same. Then we draw our little number line, and we found that 1 made the numerator 0, and we found that -4 made the denominator 0. And then we chose test points and plugged that into the original problem to see where was true, where was false. And we found that the interval that was true was between -1 and 4. Okay, so that's what we had done last time. The thing that I had inadvertently done really quickly is I looked right here and said, oh, look, it has an equals to. So that means we need to have closed circles. And that is true, except for the fact that when you're looking at a denominator, remember your denominator can never be 0. So I can't let x actually be a -4. So when I'm thinking about -4, I still have to use a parentheses there, okay, and I bracket with the 1. But when I quick wrote it down right at the end of class last time, I had a bracket with the -4, but it's a parentheses. So make sure you correct that in your notes and make sure you understand that, okay? So that is a little quirk that goes on when you deal with fractions. You always double check and make sure you're never making your denominator equal to 0, okay? Okay, does anybody have any questions on any of their homework?
I don't have a question about the homework, but is there any way where I can actually practice without benefiting my grade on my math lab?
Yes, yes. What you would do is you would go into your home screen in My Math Lab and you would click on Grade Book. Okay, and when you click on Grade Book, it will show you all of your assignments. And beside all of your assignments, it should say the word review. So if you click on that, you should be able to go in there and play with it and practice other problems without it affecting your grade. Also, it should be set up, you can double check me with this, that even if you're working in My Math Lab, it should save your highest score. So even if you did it, it should always save your highest score. But if you just want to make sure that you're only reviewing, go in through Gradebook, click on the assignment, and click on Review. And that should let you practice anything you want to without affecting your score. Any other questions? Okay, so remember that your test is going to be Friday, and on your test, you cannot use your book, your notes, your phone, no app, nothing like that, okay? You get a handheld calculator, no calculators on phones. Regular calculator, no phones, no paper of your own. You will have my paper that is numbered 1 through 20 or 1 through 23, however many problems there are. And with each number, there'll be a blank space there. And if it doesn't say that showing your work is required, you don't have to. But if you do show your work, it couldn't hurt you. It could only be used to use as partial credit. Okay? But if it says you must show your work, then if you don't, then whether that answer is right or wrong, if you didn't show your work when it said you had to, you won't get credit for that problem. Okay? All right, so there will be no assistance, no computer apps, no phone apps, no notes, no book. When you take the test, you take the test. Okay? I have opened up the review a few minutes ago, so you can look and see there'll be a review for Chapter 1. It is not graded, so you can just play with it, do whatever you want. It won't affect your grade at all. But beside it, it says that it's the review, but if you want to study the application problems from 1.2 and 1.5, then you need to just go back and look at that particular homework set for those two. All right? So that would be a good, put everything in one bucket to practice if you wanted to. So on the test, I won't choose problems from the review section. Remember, you have a quiz that's up that just kind of gets you to make sure you've done that. Does anybody have any questions that they can think of right now about the review quiz or the test that's coming? Okay.
Excuse me.
Yes.
So if we take the quiz, I just trying to make sure. But if we take the quiz multiple times, would it still take the highest score that you receive?
Yes, it will always take the highest score.
Thank you.
Sure. All right. Today, what we're going to do is we're going to do section 1.8, and that finishes all of chapter 1. One 1.8 is using absolute value. And 99.9% of the time, when you solve an absolute value problem, you're going to have two answers. And so I don't know how many times I say that. There'll still be several people who often hand me in one answer. They only do half the problem. So I always think when you see absolute value, most likely I'm going to have two answers. There are a couple occasions when I won't, and we'll look at those. But other than that, there's going to be two problems to solve. The first thing I'm going to do is just use some basic numbers so that we can get a general idea of what we should be thinking and visualizing when we think about absolute value. Absolute value means the distance from 0. So if I see that the absolute value there of x is equal to 3, my solution is going to be either x was 3 or x is a negative 3, because both of those numbers are 3 units away from 0. And it would just be those 2 points, okay? Just those 2 points. If I had the absolute value of x is less than 3, that means I want all the points that are less than 3 units away from 0. This is my between. This would be all the x's between negative 3 and positive 3. Notice that I'm using open circles there. And then if I have the absolute value of x is greater than 3, I want all the x's whose distance from 0 is more than 3. So I'm going to write this down in two separate ways. My x is going to be less than a negative 3, or my x is going to be greater than 3. So when it's equals to, it's specific answers. When it's less than, think of your sandwich, you're in between. And when it's greater than, it's pushing out. Okay? For each of these, I should be able to write interval notation if there's an interval. So just to remind us about interval notation, there's no interval notation for the first one because it's not an interval. They're specific answers, right? So for the first one, you would just list the -3 and a 3. That's brackets there. That's set notation. That's not an interval. But for the next two, I would have an interval from -3 to 3. And then this one down here would go from -infinity to -3, union from 3 to +infinity. So I just chose a specific number 3. That works with any value that they would give you, okay? So we'll start solving some absolute value problems. So this says the absolute value of 5 minus 3x is equal to 12. So when it's equal to, I'm going to set up two problems. Just like I had when I had that it was equal to 3, I had two situations. Either it was equal to the +3 or it was equal to the -3. So you see, this absolute value will be true if that 5x minus 3, that stuff that's inside, if all that stuff that's inside is equal to a 12, it makes it true. And if all that stuff that's inside is equal to a -12, it's also true. So I have two situations. 5 minus 3x equals 12, or 5 minus 3x equals -12. If you like to refer to PowerPoint or the book, on page 163 in your book, they have a little chart that draws the picture that I had up here. And instead of using a 3, they use a K. But if you like to refer to your book, that's on page 163. If you want to make a note of that, you can. All right, so notice I have two equations to solve. So now you just, easy. The hard part, or the new thing in absolute value, is just setting it up. Once you set it up, everything solving is what we've already done. Okay, so we would subtract 5 from both sides here, and then divide by -3. And do the same thing on the other side. Subtract 5 and divide by -3. We have two answers. -7/3 and 17/3. Any questions about that? So when it says equals, you set up two problems. One with the +12, one with the -12, one with the +3, one with the -3, whatever it's equal to, the positive and the negative. Okay. Notice that what was inside, I never changed that. That stayed the same. I changed the equals to part. Here we've got the absolute value of 4x minus 3 is equal to the absolute value of x plus 6. Okay, so what we want to know is, when can two absolute values be equal to each other? Well, if the stuff inside of them are the same, they're equal. And if the stuff inside of them, if one is positive and one is negative, they'll still be equal, because ultimately I'm going to take the absolute value of each one. All right? So what I'm going to say, well, maybe they're equal. Okay, that's setting the two equal. That's one option that would make it true. Or if they're opposite signs. And you can choose which one you want to change signs of. I'll just choose the second one because it's a little simpler. So either what was inside were already the same, or what was inside, one was the opposite of the other. Once I've set that up, again, after that, we're doing what we've done all along. So then you just go through and solve each of those. For the first one, I just chose to subtract x and then add 3 and then divide by 3. Notice that I said it's the opposite for the second one. So I had to put the negative on the outside with that parentheses, x plus 6. So make sure you change each sign. So like distribute that negative. And we still get 2 answers. And you can go back and plug these in to make sure that you haven't made an algebra mistake somewhere. And you have 2 answers, and notice it's in set notation, not interval notation. So that's the 2 kinds of equal to problems that you would have. And then we'll have the absolute value with a greater than and one with a less than. Any questions on setting that one up before I go? Okay. The absolute value of 2x plus 1 is less than 7. So again, you see this less than sign. All right, so you should be thinking that's the one that's in between. That's your sandwich, right? Because what has to happen here is whatever my answer is, it has to be between this 2x plus 1. Whatever value I plug in for x has to make that bounce between a negative 7 and a positive 7. So I'll have 2x plus 1 is in between a negative 7 and a positive 7. Okay, so we had a problem similar to this on a previous homework set where you have your sandwich inequality. So we're going to do the same thing to every side. Your goal is to get that x by itself in the middle. So I'm going to subtract 1 from every side. And then I'll divide each part by 2. Again, since this is an inequality, if you were to ever multiply or divide by a negative number, flip all those inequality signs. Notice that's negative 8 divided by 2, but I'm not, the part that's doing the work, the 2 itself, is positive, so that doesn't make me change the signs. Okay, so my answer here is an interval from negative 4 to 3. I'm going to write that in interval notation. So that's negative 4 to 3. It's parentheses because there was no equals to with my inequality. Any questions? Right. Suppose we had the same problem, but I just changed the inequality, like 2x plus 1. I'm going to take the absolute value of that, but I'm going to change that to greater than or equal to the 7. Now remember, greater than means I'm pushing out, right? So I'm going to have the left-hand side or the right-hand side. So to work this, I'm going to have 2x plus 1 is greater than or equal to positive 7, or 2x plus 1 is less than or equal to negative 7. Remember, this is the picture you kind of have in your mind. You're needing 2x plus 1 to land you on one of those extreme areas. Okay. And then you just solve each part. So subtract 1, divide by 2, subtract 1, divide by 2. I would, until you get really comfortable, just take the 10 seconds it takes to just graph it to make sure you're going to put your interval notation correctly. Here, this first part says I want x to be greater than or equal to 3. And the second part says I want x to be less than or equal to 4. So my picture's doing the right thing, going to the left or going to the right. So when I write that in interval notation, the left-hand side is going to be negative infinity to negative 4. Because I have two intervals, I use that big old U in between. And then I'm going to go, and now that I'm doing it, it should be a little bracket because it can be included. And then I'm going to have a bracket for my 3. Remember, infinity always uses parentheses. And since it's a closed circle, I use a bracket. And I know it was closed because that had that equals to part right there. Hey, any questions? If you have an inequality and an absolute value, this says the absolute value of 2 minus 7x minus 1 is greater than 4. Before you start trying to set up your problem, this is a common mistake, before you try to set up your problem, you have to get that absolute value by itself. Okay, so you want to add 1 to both sides first. Now you can work the problem like we did before. Okay, but you have to do that one little step in there. That says the absolute value is greater than, so it's pushing out. So I should have something over here to the left and something over there to the right. 2 minus 7x is going to be greater than 5, or 2 minus 7x is going to be less than a negative 5. Notice that one time when you write it down, it looks exactly the same. And the second time, you just use the opposite inequality and the negative of that number. So you just solve each part of this. Okay. So when you've got it greater than 5, you're going to subtract 2, divide by negative 7. So I'll do this one so that we make sure when we divide by that negative 7, we still have to remember to flip our inequality sign. And then work the other side. Subtract 2. So you have two intervals. You have everything to the left of a negative 3/7 and everything to the right of a positive 1. And it's parentheses because the inequality did not have the equals to. And make sure that when you do put it in this order that you do have the part that has the negative infinity first and the part that has positive infinity second. Any questions? There are some problems that if you're paying attention, you don't even have to work them, because we know that absolute value means distance from 0. Distance is always something that's positive. Distance can never be negative. So if I have these special cases, the absolute value of 2 minus 5x is greater than or equal to a negative 4. So before you dive in and you start working, just stop and evaluate it to see if there's any work to do. This is saying that the absolute value is going to be bigger than a negative 4. Always true. I'm going to cough. Excuse me. Right? This is always true. So if it's always true, it's negative infinity to positive infinity. This next one says the absolute value is less than a negative 3. Well, absolute value means distance. Distance is always positive. Positive is never going to be a negative number. So this would never work. This is never true. But that would be the empty set. Right. And this one isn't equals, but it's equal to 0. In all the other ones, when we had equals, we set up 2 different problems to solve. But 0 is neither negative nor positive. There's only one way it's going to be 0, and that's when 5x plus 15 is 0. So there's only one problem to solve there, so you just solve 5x plus 15 equals 0. And you just get one answer, which is a negative 3. Okay, I'm going to give you one to try. Okay, so I'm going to give you a minute. Solve the absolute value of x plus 2 divided by 2 equals 7. make sure you set it up so you had 2 problems. You solved each of those, and you got 2 answers. Now, when I wrote my answer in those set brackets, I wrote the -1 first by habit, but you could have written the 12 first because it's not an interval. It doesn't represent an interval. Any questions about that?
How do you write it so that it doesn't represent an interval?
Because I'm using these not beautiful but kind of squiggly set, that would be called our set notation. So once I see those squiggly lines, that means it's not an interval, it's set. If I use parentheses or bracket, I'm doing interval. Okay, try this one, please. 2x plus 5, we want the absolute value of that to be less than 3. So that's that one. And the second one is the absolute value of 3x minus 4 is greater than or equal to 2. So try those. The biggest thing is getting it set up correctly. After that, it's what we've been doing. And write your answer in interval notation. Okay, so for that first one, it was the sandwich, right? And I subtracted 5 from every side, and then I divided by 2 every side. If I had divided by -2, I would have flipped both of those inequality signs. Okay? And then you would have gotten -4 to 1. Everybody good with that? -4 to 1. And we use parentheses because This was just less than. And then for number 30, well, number 30 in your book, here we had to separate it because it was a greater than, so I have to have one going over to the left of the negative and the right of the positive. Okay, so I've got 3x minus 4 is to the right of 2, and I have 3x minus 4 is to the left of negative 2. Solve each of those, and because this time they had the equals to underneath there, that's why I used the bracket. And notice infinity always has parentheses, but the numbers can have brackets. Any questions on either one of those two? Okay. And then there should be in your homework one or two like this, where if you're paying attention to it, what's that answer?
Always true.
Always true. So I'm going to have negative infinity to positive infinity. What will the second one be? Never true, so that would be the empty set. That's right. And if it was equal to 0, you're just going to work one problem, right? You're going to have 10 minus 4x equals 0, right? And you just solve that one problem. So subtract 10, divide by negative 4. And I am sure in my math lab they would make you reduce that fraction. They wouldn't let you use 10 over 4. They'd make you write that as 5 over 2. Okay, does anybody have any questions so far about any of the absolute value? So the biggest thing there is just setting up your problem, right? Because once you get that, it's what we've been doing. So just be real careful about doing that. And making sure if the absolute value is not by itself, that you make it be by itself before you set it up. All right, so that's the things to watch out for. So reminders about what's going on in my math lab. Today, before I came to class, I went in and if you had things that are past due, they became zeros. All right, remember when you don't do your work, it becomes a 0. So go in there and check that you're keeping up with your work and see what your grade is. I mean, not doing your homework is going to matter to your grade. So I would do my homework. Plus, doing your homework helps you prepare for the quizzes and the tests. So do your homework. There was a quiz, and you've got another quiz that's available, that you're working on. That's the review. And you've got your test review that's open, and that is not going to be graded. Okay, so I think it has like 60 problems on it for you to play with, but it's not graded. I mean, my math lab's going to show you a grade, but it's not going to go into your overall score. It won't show up in Blackboard. Okay, yes?
Will the test be 60?
No, the test will be about 20 to 23 problems, and the test will be for 60 minutes. It'll have a little timer on there, so you'll have 60 minutes to do the problems, and there'll be 20 to 23 problems. Anybody think of other questions about anything? Yes.
I had a question on one of the homework problems.
Yes.
From the review .7 lab.
Yes.
thing.
All right. Awesome.
Number 3.
Great. See, that is an awesome way to ask a question because you know where it came from. I can find it. And is this from the review quiz that you were, is that what you were asking me about?
It just said R.7 lab.
Oh, okay. Got you. R.7 lab. And it was number 3?
Yes, ma'am.
Okay. And oh yeah.
Yeah.
We'll do that one. And let me mention this too. Remember what Wednesday is. Wednesday is review day. And just like this is exactly what your review day should be. You come in and you ask me about questions that you have. And when y'all have questions about particular problems, we'll work them. And then if you don't have questions, I'll move on to chapter 2. Okay, so you make your review day however you want to utilize it. Okay, yes, this is a great problem. A great problem. Okay, so here we have to deal with exponents. And I don't know if, can y'all even see those numbers out there? No. People out there like, we cannot see that number. Okay, let's see if I can get it written down. 256 m to the 5th, 256 m to the 5th divided by n all to the 1/8 times 256 1/4 all raised to the 1/4. So hopefully I've gotten everything down there right. Okay. All right. So what you want to do is look inside both parentheses first and say, can I clean up anything in there? If you can get rid of any negative exponents, I would do that. So with my first grouping, I can't do anything with 256 m to the 5th or n. So I'm just going to leave that one alone. But for my second grouping, I have that n to the -1. And since it's multiplied and divided, I can drop that down to the denominator so that I can have it as an n to the +1. So that's what I would do first. So nothing to the first part first. But I would bring that n down so that now I have just positive exponents to work with. Okay with that? Okay. Now, because everything inside those parentheses is either just multiplied or divided together, I can use my exponential rule and say, okay, really what I'm doing is 256 to the 1/8, m to the 5th to the 1/8, and when I raise powers to powers, I multiply. So that's really going to be 5/8 on that m power. All right, and my n, which has a 1, will now have a 1/8. Okay, same thing over here. I'm going to have 256 to the 1/4. And then my m to the 1/4 will become n to the first power. And my n would become a 1/4. Okay. Okay. Off the top of my head, I don't know. What is the number that if you raise it 8 times, is it 2 times 2, 4 times 4? What number is it that you raise to itself and you're going to get 256? You're going to have to do it 8 times.
It's 2.
It is 2? Awesome. Okay, so it's 2. So 2 to the 1/8 is, 256 to the 1/8 is 2. Are you okay with that? Okay. And then what is 256 to the 1/4? What is that? 4.
Wait.
Is it 4? That's right. Okay. All right, great. Okay, so now I can go ahead and say 2 times 4 is 8 because everybody's multiplied together. And I'm just rearranging the order of the ones on the denominator. They're multiplied together. I can change the order. All right. So now what I've got to do is I'm going to deal with my m's. I'm dividing like bases, so I'm going to subtract exponents. And this m, which is a 1, is the same thing as an 8 over an 8. So that's 8/8. All right. Now, this is where I think it's easier to think to myself, I'm going to be subtracting, and I just need to know where is my answer going to end up. And so if I had something like m to the 8th over m to the 3rd, let's say, I would have 8 of them on top, 3 of them on bottom, so I'd have 5 of them left. So the answer here would be m to the 5th. But if it was m to the 3rd over m to the 8th, then I would have 5 of them left on bottom. Same scenario here. I have 5 8s on top, 8 8s on the bottom, so I have 3 8s left, but it's left on the bottom because I have more. All right. So this is going to be 8 m to the 3 8s on the bottom. And then I'm going to have n times n. They're like bases. I'm going to add those exponents together. So I'm going to have a 1/8 plus a 1/4 when I add those together. So that's 2 8, so that's 3 8. So n 3 8. And there you go. And technically, you know, how they haven't let us leave radicals in the denominator before, technically if they were going to go on with that, they shouldn't let me stop there, but they do. So they let us stop right there. Did that help wherever it was that you were having a mistake? Okay. Any other questions? But that's perfect. That's like Wednesday when we come in here. If there are any problems that you're not sure of, tell me what section, what number, and we'll go and do it. Okay? All right, so I'll see you next time. You're 5 minutes early.